Hi, I'm Dave Robinson. Welcome to another screencast. We'll be using R and R Studio to analyze data I've never seen before. As usual, this data comes to the Tidy Tuesday project, an amazing weekly data project in R run by the R for Data Science online learning community. So I took a minute to get set up here, but I think that I'm streaming now. So if I'm streaming, somebody please let me know that they can hear me, and I'd greatly appreciate it. But assuming that people are listening, as usual, I'm screencasting this live, and I'm excited to hear if you are here live. I'm excited for you to share your ideas for analyses and graphs you want to see, your questions about the code. That's really one of my favorite parts of doing this live, is getting that kind of live feedback. I can see your comments. Thanks for letting me know it's streaming now. That's great. It looks like it's working now. So let's see what data we have this week. It's Ask a Manager survey. So a salary survey, 24,000 people sharing their salary. And it's not a random survey. It reflects Ask a Manager readers who self-selected to respond. The demographic breakdown below is very white and very female. That makes sense when you're doing an online survey. It's great to get a large number of respondents, but it doesn't mean that a large number of respondents does not mean one that's reflective of a general population. But I'm excited to see what we can learn from this survey. I used to work with a salary survey called the Stack Overflow Developer Survey that included a lot of data, including income. You can see some of my blog posts about that on the Stack Overflow blog. And all right, let's see what we have here. It looks like it's one data set, and let's load up. Here we are. Tidy Tuesday R. Use Tidy template. Let's get started. I usually like to add in library scales. I like to do theme set, theme light. And there's one data set, it looks like survey. So do I see anything in here? Yeah, what do I see that we might need to process? Well, one is that this is a month, date, year, and hour, minute, second, but it's not processed. We also have a lot of categorical ones. And then we have some annual salary that is luckily that is numeric. We have a currency other. Did we have any correction for currency, like a translation for currencies? I don't see anything immediately. Country is it looks like it's a free text field, so people could put in United States or US or USA. Put a state and a city. All right, I'm seeing a lot of kind of data cleaning we might want to do for the so because some of these are categorical, some of them are free text, and some of them are and some of them, things like 25 to 34, might be categorical, but we're going to want to turn them numeric. We're going to at least want to order them if we want to see, like, if we want to try ranking people by their age or experience. We want to try dividing that up. So let's start with the simplest kind of clean I think we might want to do, which is that if I load in the Lubridate package, we might want to do timestamp equals MDY, MDY HMS of timestamp. That is processed into month, date, year, and then hour, minute, second. That'll let us process it a little bit more easily. How old are you? 25 to 34. I wonder how many values of how old are you that you are there. All right, one thing I can see is that I really want to order it based on the first number in it. Here's a nifty trick for that. I can do I'm going to call it age category. Is FCT reorder. How old are you? Based on the parse number of how old are you. That parse number grabs out the first number generally. And I want to put like 18 first, and let's see. I'm going to call this survey. And let's see now, how does age category? Nope, it didn't order it correctly because I think this under 18, it did not parse it out and put this for, oh, that's because I have sort equals true. Aha! That is close but no cigar. I need to put under 18 first, so I'll actually throw in an extra one where I say FCT relevel. Relevel brings at least one value to the front, so I'll say under 18. Put under 18 as the youngest level. Here we go. Okay, so we can see it's largely the population is really 25 to 44 is a large majority of the respondents to this survey. All right, so so that industry job title, I wonder how whether these are free text. They are, at least industry has an other category, because we can tell some of them are really common, but then there's a really long tail of people putting other terms in. That's worth noting. The okay, and that survey, I'm guessing the same is true of job title. Let's find out. 12,000 distinct job titles. How many people are in this survey? I forgot, I neglected to say 26,000. So people can put a lot of things. They could put software engineer, project manager, but they could put a long tail of things. We'll see how many data scientists there are in the data set. All right, so we got a couple categorical things. And there's additional context, and we have annual salary. That's numeric. Let's take a quick look at the annual salary. And usually we want scale x log 10. And I haven't dealt with currency. So these could be people that mistyped something. They could be people that are trolling and say they make $99. It could be a lot, but it looks like most salaries kind of fall into this range. Which, if I did a quick filter, now I'm gonna need to work with current. Actually, before I do anything with salary, I'm gonna take a look at the currency column. Okay, most respondents were US dollars. Then we have a few others. I'm gonna, for the first look, I'm gonna just look at currency USD and filter for annual salaries greater than 1,000. Annual salary is less than, let's do less than 10 million for starters. And we kind of see there is a little bit of tails on both sides. I'm gonna do one that it is possible to have absolutely possible to have a salary above $1 million or below 100,000. I'm just gonna keep this so we can get a little bit more of a sense of distribution here. So it looks like we're looking at a mode a little bit under 100K, and then but this is what we call like a log normal distribution generally. So salary has like all right. So we have log normal distribution. Peak a little bit below 100,000. I'm going to change that to be labels is comma format. And actually not comma format, I'm going to do dollar format. That looks nice. Annual salary. So this is our distribution. Like I said, I want to do log because if I drop the log scale, it would look like it would look a lot more skewed. You can't go below 0, at least with this clean data set, but you can get pretty high. I'm going to leave in less than 2 million. It is absolutely possible people above 1 million are trolling, but it's certainly at some large tech companies you can get above a salary above $1 million a year. So I'll leave them in just for the time being, and I'm gonna save this version as survey USD. This is like a filtered version of just 10,000 to 2 million on people that give their salary in USD. This is the survey USD. Yep. Okay, I'm doing that because there's probably various kinds of machine learning I can do on this data. I'm going to set 5,000 as a minimum. It is possible for particularly things like internships to make salary below 10,000, but yeah, I might kind of start here. All right, and this is taking a look at the reason I pulled this out is that I might want to do a couple of questions like how it differs between job titles, so or between industries. So let's take another look at this. Okay, we also I've got a couple of things. Let me look at country. Would look at that. I filtered for only survey USD. So a lot of these countries are going to people that report in the United States. Going to be many different ways of saying US. Looks like some people, Canada, Australia, reported their salary in US dollars, but mostly people that put United States. That makes me feel like if I'm just starting with the US before I look at currency translation, this will be entirely reasonable. I also want to take a look at state. 125 states, which means some people might have put in, people might have put in multiple states. I wonder if it was a multiple select. I think it might be a multiple select. Just noticing that we don't have random values. I don't see any misspellings, but I see multiple select. Oh, I can take a look at the documentation for it. It doesn't say this, but it looks like it states. All right, and that could be interesting to see California versus New York versus Massachusetts versus Texas, etc. In fact, let's give that a shot. So what I'm going to do is I'm going to count only the first state for the first state people are in that they mentioned. So by doing that, I'm going to say state is string remove state comma and then anything, comma space and then anything. And now if I count state, I suspect it'll be 51, 52. Maybe there's a bit of missing data. I don't, oh, there it is. There's some missing data. All right. But the reason I do 51 is 50 United States plus the District of Columbia. So so if I only count the first state that they mentioned, just makes things a little bit simpler. Then I can do survey USD mutate state is FCP lump of state into the top, I don't know, 6. And then ggplot, I want to look at a distribution of annual salary by state, geom box plot, scale x log 10, labels equals dollar format. And I'm going to add one extra step here where I say state is FCP reorder state by annual salary. And I'm also going to do a filter not as an A state at this level. Okay, so one thing I can see here is there's not on a general distribution, it looks like California might be the highest, other might be the lowest, but the fact that there's so much more variation between states as within states means that I'm probably not going to look at a distribution. I might just want to look at a median. Ooh, answer of question is string remove is neat. What package defines it? String remove comes from this. str remove comes from this string-r package, which is a lot of useful functions. Str detect, str match, str replace that are really great in string-r. It is automatically loaded by library tidyverse. So I'm going to try a different approach here. We're going to do group by state, summarize, always want an n, and average salary, median salary. And I'm going to actually turn that into a pattern where I say summarize salary. And just use the exact same summarize. Here we go. So now I'll do, so now I'll say summarize, and let me throw in an arrange. It's always nice to do arrange descending n. I might just use this again, is why I think I'm interested in it. And yeah, this gives a better sense that, okay, the median salary reported by California respondents, 101,000 a year, compared to 72,000 other, you know, lower. It's a little lower in Texas. It's pretty high in New York. We can do this as a bar plot instead of as a box plot. And do, here we go. Median salary. And I do not want log 10 if I'm doing a box plot. Pardon me, a bar plot. But yeah, this gets the idea across. I might even do the top 9 plus other. And yeah, so California, Washington, District, Columbia a little higher, Pennsylvania, other a little bit lower. I bet this lines up with general national trends, though. We'll see how this plays with other things like industry. So I mentioned industry, and I think that's neat because remember we saw industry was something where there were a few really common responses, but we do industry sort equals true. There, yeah, here I can kind of see, okay, there are at least, I could do the top 9 or the top 8 and then other. So I'm going to actually use a very similar code and do not is an A, and so really a very similar pattern. Not is an A, industry, so much so I could consider turning it into a function. Yeah, so what we're seeing here is that the highest salaries in this data are computing tech, lowest in education. I'm definitely going to be fitting a model to this data, maybe a regularized regression, because I think predicting salary from your data, like your industry and your experience, is going to be really interesting. I'm going to pull this out into a function. I've done this exact same pattern twice, and I'm about to do it a third time, which means I'm going to want to turn this into a function where I'll say, thinking about this, plot categorical, tibble, and column. Column will be given as a bare name, and I can use this tidy eval approach where I say, here we go, column, give it double braces, and then replace anytime I say, and I'll say n levels is 9. And notice it's always the same thing. So we remove missing data, we lump the rare values, we reorder, we group, we summarize, and then we plot. And this didn't work. Oh, because I need to, somewhere I have a missing parenthesis or an extra parenthesis or something like that. Let's see, does this, yeah, there's an unexpected parenthesis. I'm actually just narrowing down where might the extra parenthesis be. Not here, not here. Unexpected equals sign. Where is there an equal sign? Here there's an equal sign, and let's see. Does anyone see it yet? I haven't seen it yet. All right, the problem was not here. Mutate this equals this. Oh, here it is. Okay. Yeah. The challenge is the the challenge is that if I want to name a column by something, this one's not going to work. I'm going to need to remind myself what the way to do it is. There is a way to do it, and I'll remember it at some point. But I'll do plot categorical state. Hey, oh, I was wrong. This just works. The reason is when I do this something equals something, but I use the double braces, I need an equal. I need this, I forgot what it's called, but colon equals. So this is tidy evaluation, and it's really powerful because I just put the word state in, and it basically stuck the word state in each of these steps. And I can put the word industry in, and hey, here we go. The computing tech, law, engineering, manufacturing, healthcare, etc. So much so that I'm going to do labs median salary, industry, and survey USD, plot categorical job title, and yes, we have job title by median salary. All right, so I see. And here, yeah, we can see huge gaps by job titles. Senior software engineer, director. Interesting that senior software engineer, I would not have expected it to be higher than director, but I guess this could be the, I guess this could have to do with years of experience. You might have directors at startups versus senior software engineers with 10 years of experience at tech companies. There could be a lot of differences that cause that. It just wasn't what I would have predicted off the bat. Hey, what would I say if I did, instead of just job title, like, what if I did not just the top 9, but the top 15 plus a category for other? Okay, we see senior software engineer, associate, I'm going to assume, is at law firms, and then we do the, and then we go all the way down to like paralegal administrative assistant. Okay, yeah. So we're really having combinations of job titles and industries here. That are going to be some really interesting. Who do some really interesting predictive modeling with that. So here we go. I think I'm going to pull out tidy models because I'll go back into why I'm going to pull out tidy models in a second, but let's do a little more exploration first. We were looking at, let's see, oh yeah, we certainly would want to do overall years of professional experience. Now is that binned? If I did overall years of professional experience sorted, here we go. Yeah, some of them are pretty low. Yeah, it is, and I'm just checking. You can use the first number. Yep. Okay. So I can actually do this in the same cleaning step. Remember how I did FCT relevel right here? I can do FCT reorder. I can do overall years. I'm going to call this. Please call this one experience. Overall experience. Just because I'm going to have a hard time retyping that whole long column name. And now if I do a count without a sort, 1 year, no, nope, this didn't work. Oh, it's now called overall experience. Oh, I need to rerun my survey USD filter. 1, 2 to 4, 5 to 7, 8 to 10, 11, etc. Yeah, so this is pretty good. One thing I'm noticing just is that there's sometimes spaces, sometimes not. That's bugging me just a little bit. So I think what I'm going to do is throw in. Here's what I'm going to say. Overall experience is. Okay, first I'm gonna change how I'm doing the renumbering, and then I'm going to say is overall years string replace this. I'm going to replace any space without spaces. I'm doing this just as two things in sequence, so that if I count overall experience, now here we go. There's never spaces. Just we could have kept always spaces. I'm going to go with never spaces for this. Yeah. And now there was one other column about experience. Where was it called? Years of experience in field. And yeah, the same situation. Yep, exact same situation. So I can take these two and do years of experience in field. I'm going to call this experience overall. I'm going to change my naming convention halfway through just because I want experience in field and rename each of these. Let's fix the data cleaning just a little bit because I want to have okay count experience in field 1 year, 2 to 4, 5 to 7, etc. All right, now that I've done this, we can look a little bit more easily at like these at some of these plot categoricals, because I can do survey USD plot categorical experience. Oh, I need to run this step again. Here we go. And this makes sense. The median salary does increase with more overall experience. Not quite. These two are really close but don't quite line up. And that actually shows something here, which is in some situations I've been reordering by the total. Some situations I won't want to. So I'm going to say lumped table. I'm going to split this out. And then here say if, let's say, if reorder, then lumped tibble is lumped tibble. I'm rewriting this function a little bit so that it can cover a wider variety of use cases. I'm going to do, here we go. Lumped tibble, yeah. And let's see, somewhere there's going to be something up. There it is. Whew. And let's try plot experience. Now it's reordered, but if I do reorder equals false, perfect. So see, this goes 1 year less, 2 to 4, 5 to 7, 8 to 10, etc. And then we have 41 years or more. And we notice there's like, it's not once you get to 20 plus years in this data set, at least among this respondents, there isn't a clear increase, maybe some kind of diminishing returns. But you can definitely see a difference between 2 to 4, 5 to 7, 8 to 10, 11 to 20. This makes sense to me. All right, I'm also going to do age category. Let's see. It's certainly going to be correlated with experience. Those aren't the same thing. But if we take a look at age category, under 18, 18 to 24, 25 to 34, it makes sense. People 25 to 34 might have around 10 years of experience. It's kind of lining up, though of course there are career changes where you don't see a huge shift after, like after 44, there's not a huge, there's not really a continuing trend. And what if I do experience in field? I wonder if that's more tightly related. In field. Cool. 1 year, 2 to 4. Yeah, we can kind of see here. You know, I don't know if this is a tighter relationship than experience overall. Let's see between these two. It's so that it looks like maybe it is. Like I'm noticing this one tops out at 100K, whereas this is our experience in field. Experience overall, top cell, this is below 100K. Okay, so that actually gets at an important thing, which is how can we tell which of these explains more variation? In fact, I might want to ask that about any of these categories. How can we say how much variation is explained by one of these columns? So one of these categories. So this gets at a fun statistical test we're going to do, which is ANOVA. ANOVA is analysis of variance. It tries looking at the variance between within groups and compares to the variance between groups. So if I were to take the here, if I did, excuse me, if I took one of these, like if I took, like, let's say Survey USD, and I went back to doing a box plot. Where was my box plot? I got rid of the box plot. That's fine. If I take Survey USD and I do filter not is in a, let's say, experience overall, and I do annual salary by experience overall, geom box plot, scale x log 10. What we can get is say, okay, there's variation within each group and there's variation between each group. What percentage of the variation does the group explain? Since this data is log normal, we already saw that putting a log scale made it look more like a bell curve. We're certainly going to want to do it on a logarithmic scale. We can do this with what's called, with ANOVA, based on a linear model. So we would say our data is Survey USD. And we want to explain, actually I'm going to do some lumping first, now that I think of it. I'm going to say experience, I'm not going to do that with experience, so I'm going to get to this later now that I think of it. I'm going to do explain log 2 of annual salary. Could have chosen any log, but log 2 tends to be more interpretable, based on experience overall. This just got me a linear model with 8 terms, one for each year of experience. That's not terribly intuitive, so I often turn it into a summary. So this tells me, okay, I've got an intercept and then all the other levels. Each of these gives statistical significance, but it's about statistical significance relative to an intercept, relative to, in fact, 1 year of experience, saying how confident am I that someone with 5 to 7 years of experience has more experience, someone who has 1 year of experience, has higher salary than someone who has 1 year of experience. What if I want to know how important is this level overall? Well, then I'd pipe this actually to ANOVA, and I get, actually, let me remember myself very quickly. No, it's ANOVA. I do ANOVA, and then I'm trying to remember if I get a summary. Nope, not summary of ANOVA. I actually like, I use the broom package to get to tidy this and get things like the sum of squares at each level. So actually, where is the? Oh, I take that back. I can use ANOVA, but I can also actually take a quick look at our linear model and notice. I'm going to get back to ANOVA in 1 second. Apologies. What I notice is R squared. So R squared represents the how much of the variation in salary, this whole variation, are we explaining based on these categories? Here it's saying 5.8%. It's not that low, but we can tell there's a lot of variation left over. And I might want to ask a question like, okay, that's experience overall. How about, that's just this one. How about experience in field? Does it explain more variation? Type the summary, and the answer is yes. Experience in field is a better predictor. We can tell because it explains more of the variation, 10.7% rather than 5.6%. We can use it. We can use adjusted R squared, which takes into account how many categories we have. Truth is, here we have so much data, 21,000 data points, that this number of predictors is not that groups is not that. Doesn't impact our R squared that much. That's why the adjusted is so close to the R squared value. But yeah, we learned that, okay, experience in field might be a better predictor than experience overall. All right, how about job title? So like, if I just use job title, how would that be? If I say, now for that, remember there's way too many levels. So I'm going to add job title is FCP lump of job title. Top, I don't know, let's say top 10. And then I pipe it in while using data equals dot. Director, executive assistant, we see our values before, and they're comparing them all to some value, which we actually don't even know what it is in this case, whatever was alphabetically first, which I think is assistant. But that doesn't matter because I'm mostly interested in the R squared, how much explanatory power do these 10 job titles have? Answer is not that much, maybe a little less than experience in field. So this is like a way that we can try saying, okay, this category explains some variation, this one doesn't. So I see a couple questions. One is, why do I often use log2 in the screencast rather than just log? The answer is that it makes these values a little bit more interpretable. I'll give an example. Here we're comparing all of these to assistant. We could have changed this and be comparing them to something else. How do I know the assistant? Just because I happen to remember that the first one alphabetic, I said assistant, it's to associate, isn't it? Or no, it's to administrative assistant because this was to 10 levels. Aha, this is what happened. Okay, yes, we did on 10 levels and it was administrative assistant. So then if I look at this model, this intercept represents the estimate for administrative assistant. What do these other terms mean? They're more interpretable if we're predicting on log 2. Here's how a 1 on this scale would mean twice the salary of an administrative assistant. A 2 on this scale would mean 4 times. That is 2 to the power of 2. So so I just like that I can say, a program manager and project manager make almost twice what an administrative assistant makes. We can kind of confirm that. It's between about 40K and a little under 80K or so, something like that. So we can see, okay, about twice. Senior software engineer makes nearly, they're not quite 4 times what an administrative assistant makes because the coefficient is close to 2. So if I were doing that on log, it would be on base E. So that's really important. So it just makes these coefficients more interpretable. So that's important is watch this R squared, 0.04128. If I do a regular log, still 0.04128. If I do log 10, still 0.04128. The point is this doesn't, and the p-values are all exactly the same. All these log transformations are just differ by particular constants. That's just math that comes out of the log. So it's not like changing how predictive my model is. It's not making one term significant when another would be. It's just transforming these into a more interpretable scale. That's why I love log 2. All right, so that was looking a little bit at job title. Top 10 job titles, a little less predictive than state. I wonder if I did 20 job titles. Maybe, so pardon me, I said state, but I meant then years of experience. Yeah, maybe job titles a little bit predictive. A little bit more predictive if I use more levels. Though you rapidly get into p-value, p-hacking territory there and want to do something a little bit smarter. I'm going to take a quick look at one other term. It's really no surprise that all of these are making some kind of impact. If I want to combine all of their impacts and try comparing them relative to each other, the best way is to add all the terms together. To sort of say, here, I'm doing job title. I'm also going to do, I'm going to do state. And only the top of the 10 most common states. And I'm not going to do experience overall and experience in field because while I haven't checked, I suspect they're extremely correlated. I'm just going to use experience in field because we saw that one was considerably more predictive. And if I take this and I do a summary, then combining these 3 terms, the state, the experience, and the job title in a linear model, I'm able to get to an R squared of 21%. So explain 21% of the log variation, and but this doesn't get me quite to what I might be excited about, which is which of these is the most explanatory power once they're combined. That I would use ANOVA, which now breaks it down into the variation explained by each of these 3 levels. I can pipe that into tidy from Broom and turns it into a table. And I like to use, let's see, they all have very similar degrees of freedom. So I'm going to do percent, this certainly doesn't come with it, but percent of variation is actually the total variation, sum of squared. Oh, pardon me, it's the sum of squares within each level divided by the total sum of squares. I don't have time in this screencast to explain how that works, but it's about, 4%, 6%, or 11%. Of the variation explained by each of these. So that's how ANOVA works. We can actually explain multiple levels. Okay, here's how much this category explains. Couple things going on. One note is that while job title and state are properly categorical, experience and field is not really categorical. You could turn it into a number. It certainly is ordinal. Since there's 7 categories and it's very predictive, it's probably not that bad to treat it as a category. But it's one note. Let's do some machine learning. So one quick question. Would you get the same r squared if you don't do log? The answer is no. You would absolutely not get the same. If I did, let's say here, this step, if I removed that was 5.5%. If I removed the log, that actually wasn't even that different. One was 5.5%, one was 4.1%. It could have been a lot hairier. The reason is that salary isn't on a normal scale, and usually when you use r squared, you're looking for something with roughly a bell curve. There's theoretical reasons for that. It really is designed on some normal assumptions. There are cases where it will work pretty well with, even if it's not a bell curve. There are cases where it works very poorly. But no, what I'm doing is I'm looking at the percent of variance explained on a log scale, and yeah, you do get different results from log versus not logged. Good question. Punyan had a really good, so my old colleague Jason Punyan had a really good question right now, which is about additional categories we can look at, like gender and race. I completely forgot, and this was in the data set. Just looking at the first couple columns. One is, I'm gonna leave in reordering. Okay, in this data set, men make more than women. So there's definitely well-known reasons for that involved in things like gender gap and discrimination. There's also likely confounders in terms of things like industry, job title, and experience. So so we see men make the most, women make the then prefer not to answer. Then I'm going to lump these two together. Prefer not to answer. I'm gonna lump them just because I don't know how many here are other and how many are prefer not to answer. So I'm gonna say let's see, I'm gonna add FCT collapse gender to I'm gonna do other or prefer not to answer is both this level and prefer not to answer. This could have been a survey, for example, this could have been a survey question changed partway. And I need to rerun my survey USD line. Yep, so okay, men, other / prefer not to answer, women, non-binary. So there's some clear stories there, though. As I said, we're going to want to control for some other things before we make too many conclusions. But we can also look at, where is this? Yes, race. Race in this data set is categorical, and I could lump them together, and I'm not necessarily going to write here. Okay, well, we do have multiple, a couple levels that are multiple values. So if I did count race sort equals true, we could say Hispanic, Latino, or Spanish origin, comma, white. I'm going to lump only the first 4. These are much smaller levels, and I think it's going to be hard to draw conclusions. And there's also in other categories the 5th most common. So that if I say N levels is 4, now I get Asian American, Black African American, white, Hispanic, Latino, Spanish origin. We don't see a racial pay gap in this data set. There could be a lot of things that are confounding that. But just at the top level, we're seeing largely higher salaries among Asians and Asian Americans that answered, and less gap among other races. All right, we'll see once we. Let's add that into our ANOVA. So what I'm going to do is we already collapsed this, and I'm going to add this. I am going to do race is FCT lump race 4 at the top level to put everything that's not I'm going to also do coalesce. Now I'm going to do coalesce this and other. Coalesce replaces missing values. Doing that because I think of missing data as similar to other, or you could say other no response. So coalesce just replaced missing ones. All right, let's take another look at that ANOVA. This is, again, it's not a random sample, and it is a really, it's not a random sample where we're taking only like a first glance at this question. But if we take a look, where is my data? Here's my ANOVA. I'm going to throw in gender and race. So in terms of variation explained, gender pops up, pardon me. Gender is a category. I only see 3 degrees of freedom. Is that, okay, that's because we have 4 levels, male, female, non-binary, and other. And so we see 3 degrees of freedom alongside those. If we're looking at what explains the most variation, there's 75% unexplained variation. And I'm going to arrange descending PCT variation. A lot of unexplained variation, experience in field, state, job title, then gender, and then race, as explained the least variation. So this is saying that controlling across this set, we do see some variation due to gender. So even controlling for experience, for state, for job, and for job title. Oh, I neglected to do industry. So we did do a graph of industry before, but I'm going to do just the top 10 industry FCP lump. Oops, I did this, but I didn't add in plus industry. Okay, using industry, yeah, once we throw in industry as well, we do see, okay, that explains a lot of variation. That actually, it's interesting to me that it didn't chop out a ton of the existing variation. Yeah, the, cool, it's almost well, sorry, so we're noting that industry is also very explanatory. So we certainly want to include experience in field, industry, state, job title. We likely want to include gender. Race explains a bit, oh, why do we have 42 degrees of freedom for race in this data? Is that all right? I think, yep, that would be an issue. I think that what happened is I didn't rerun this line after I did the lumping. So here we go. Okay, yeah, once I reduce it to 4 categories, this explains a little bit less variation. So that's one. This is one finding. And all right, so we're seeing 64% unexplained variation, and then some of these explain others, explain some variation with a linear model. Some of the reasons that we have unexplained variation would include that lots of industries and job titles don't include in the top 10, or if that matter, states aren't included in the top 10. There's also variation between, there's also variation within experience in field. 11 to 20 is a large range, and there's there's also many other reasons that 2 people that are working in the same industry, similar job title, same state could be making more than each other for lots of potential reasons. All right, so one question from James, which is what's the significance of the degrees of freedom? The answer is this is how many categories we lumped these into. So so here in experience in field, we gave every experience in field level. There were 8 levels, and here I'm going to pop them up again. There were 8 levels, and every one of them got its own term. So the reason we have to keep track of experience of degrees of freedom when we're doing ANOVA is that we could overfit. We could have add a category that has 1,000 levels, and everybody gets a different, and every one of them gets a different estimate, and that lets us make it a very precise estimate and get very close guesses, but it's not very informative. We're really just overfitting and noise in the data. So there are ways to adjust degrees of freedom. I was just starting by looking at I want to make sure none of them were too high and kind of kept them consistent. But that's again not a terribly precise approach. Okay. So so we took a little bit of a look at how what affects salary on a log scale the most. I'd be really excited to do some machine learning. I want to try tidy models, and I'll tell you why. Is that on June 22nd, I'm going to be competing in a competition called Sliced, which is run by I think Nick Wan and Megan Risdal. Where I'm going to get a data set I've never seen before and try and fit a predictive model and get as high accuracy I can in 2 hours. So that means I'm going to have to going to have to fit a model without having seen the data before. And honestly, I'm not that practiced in fitting models. I'm more interested in some exploratory analyses like I tend to do. So I'm going to be interested in practicing tidy models over the next couple of months to try, let me see, I think I have about 5 weeks till the competition. And I'm going to be trying out, practicing a little bit how we might fit predictive models. But that means you're going to have to bear with me as I try these things out. It's not the first Tidy Tuesday I've done them in, but I'm definitely a little rusty. And yeah, I'm excited to jump in the competition with a bit of practice. So let's see. Let's go about using the tidy models to predict salary on a log scale. So a couple things I'm going to do. I'm going to use initial split to divide my data up. I'm only doing survey USD on the filtered set. And so James, the name of the competition is Sliced. They already have the set of 16 competitors, so I'm going to be competing in a group of 4 on June 22nd, market count, and in the evening. And they already set up the list of competitors for it this year. I'm excited about it. Now I'm going to I'll go with the default of here. I'm going to set seed 2021 because I want to rerun this and do split survey. I'm going to call it survey USD split. And I can get the training and testing data. I spelled this wrong. And now my training and testing data are separate. Here we go. This is how I'd use our sample to pick a training and a testing sample. Great. And the next key is I'm going to need to go through the steps of data cleaning. And something here is I don't want to just lump the most common ones. The most common ones might be different between the training and testing set. I want to create a recipe. And let's see if I remember how to do that. I might be looking up some documentation. Here we go. Hooray. Okay, so what I'm going to do is I'm going to take my, do I take the data or do I take the training data? Oh, I take the training data. Great. So I'm going to take this data and I'm going to recipe. I want to take to explain log of annual salary, log 2, I should have said. So I probably can do. Yeah, I can probably do that as a step mutate. Okay, I'm gonna explain annual salary, or can I? Yeah, maybe. I can. Okay, great. So I'm gonna do explain annual salary by well, let's add some of the ones we already had. We know we will be using, like job title, state, experience in field, gender. I'm not gonna include race since it looked like it wasn't that predictive. I can include it, and we might see whether it matters or not, and industry. Now the other key is I'm going to add steps to this of what processing am I going to do. One is step mutate, so I can say mutate annual salary is log 2 of annual salary. So I know I want to do I want to transform that. I can also do, I think it's step. Where is lump? There should be a step somewhere that is put rare values. I really thought it was step lump, but it's been a while since I did this. How can I say take the other, where is it? I want to use step because, does anyone know what it is? I really wanted to do a step where I took the rare values and stuck them all into step other. Thank you. The main reason I want to use this rather than FT reorder is that it's going to depend on the training data. Thanks. So step other is going to be, let's see, and let's do that's nifty. I can say threshold equals 0.01 I can say, all right, the one or more selector functions. All right, so I can do, cool. So I can say step other and take job title, industry, and state, and say anything that is rarer than, let's make it 0.05%, put that in the other cap. We'll collapse those into other. So the, all right, and then we do job title, industry, state, and see that this threshold is said that then the rate of occurrence is below threshold will be turned into other. Great. I like the 0.5% because it, and yes, so I'm going to call this recipe. Recipe. So this is the set of steps that we'd run through for cleaning our data. You see, I already did some of these steps before. Anything else that I'm going to want to use? Any other columns I want to use? I used gender, I used race. I used experience. Ooh, education. I totally missed this. Highest level. Oops. So if I do salary, what is it? Survey USD. Yeah, the I'm gonna throw that. We know we don't need to. We can just use that as a predictor. It doesn't have too many. It really doesn't have too many levels. I wonder. And what is the one for replacing with? What is the step for replacing with missing values? Is there one that just replaces with missing values? Coalesce. I'm not guessing these well. I can drop missing value. I can certainly drop missing values. Can also try imputing them. I don't. This is cool. I can actually log. I can do step log. That makes it just a little bit more specific. Step log annual salary base equals 2. I just like that because now the recipe will say log transformation, which I like. But what is the step that will drop missing values or will replace missing values, you know? Wouldn't that be nice? Oh, well, at the very least, I do need to say, I'm not sure, but I do need to say step dummy of all the categorical variables, which includes job title, state, experience in field, gender, race. Actually, I think basically all the predictors need to be turned into dummy variables. All right. And if I take this, and now I'm going to quickly remind myself, there's a function, something like, I can't remember, is it bake or juice, or it's a fun, oh, it's a prep on recipe. I'm going to call it just rec. Prep rec training equals survey USD training. There are new levels in factor. Okay, so it's complaining about the NA. Does anyone know how to replace missing values in a step? I could just do like a coalesce somewhere, but the I really always want like no time like the present to learn. Ooh, all nom. Oh, thank you. Yes, this is nifty. All nominal. Dummy variables from all nominal. All right, let's see. How does that look? Oh, this is a prep, but it's not telling me. Oh, I can prep it, but I get it. Prepping it. All right, I'm actually going to do prep on this. Where the point is that this keeps track of some things like what are the other variables. Prep sets this up just on our training data. Though I'm not going to want to do, no, okay, I'll do that, but step NA omit. Step NA omit. Remove observations. I don't know that I want to remove observations. I think I might want to just treat them as missing. So I think what I'm going to do for starters, I'm going to say step mutate. I'm going to say job title is coalesce. Job title missing. I'm going to throw in a couple missing steps. So I'm going to do, and I'm going to do industry is coalesce. Industry missing. It will still get lumped into other. And let's see. Don't think experience in field had missing data, but I know state did. I'm setting this up because I don't think I'm just saying that I want to treat these as though they're other values. which is not always a good idea. But, well, at least one of these is still, are not factor variables and will be ignored. Highest level of education completed. Oh, then maybe I don't want to say all nominal. Maybe I want to say, this is step string to factor. Here, I'm still learning how to do this. Haha, didn't work. Oh. Didn't like that one bit. Oh, I get it. I see what happened. And then throw a factor into here. Ooh, what's step unknown? Ah, thank you. I actually didn't realize, like, using a package that I'm less practiced in, how incredibly useful this approach is. I love this. Step unknown, job title, industry, state, highest level of education completed. Does it have a default value for a new level? That new level, that's fine. New level unknown, that's fine. Ah, thank you. And I'm also going to do step mutate. Apparently this needs to be a factor. Really thought that it would have. I don't understand what's going on. Yeah, I can. This still looks pretty good. So this is coming up with a recipe, and the key is that I'll be able to apply this recipe to each of the training sets. By the way, I started a little bit late, and I'm going to keep going, so I'm going to finish a little bit late. So I expect about 15 to 20 more minutes. Of course, you're welcome to leave. But yeah, I really did want to try out a little bit of machine learning on this data set. All right, so let's try. Oops, right. All right, so once I set up the recipe and then I prep it, which means I specify, like, okay, now I'm going to fill in the things like step other. It's going to be other based on that training data. And now if I say bake the recommendation with the survey USD training data, now I get my dummy variables and my everything. I can say, oh, okay, I get my industries, I get my education. Now, how many? Yeah, so this ends up being turned into 87 predictors predicting log of the annual salary. So this is like my data cleaning process. I've created a recipe that does that data cleaning process. Let's see if we can figure out that new levels in a factor NA situation. I just don't love it. I thought that this would have. I wonder if I did this, and then if I removed these other steps. No, it's one of these steps is causing the problem. Let's see. Oh, it's the step. That makes sense. It's the step dummy. Which thing is it? Step other. Which thing is it running into a problem with? Job title. I really thought. Huh. Well. I changed my mind on whether. Yeah. So training prepared. I can set up my training prepared if I want, but all right. So this was setting up my recipe, and if I want, I could look at the clean data. I'm actually not going to be looking at the clean data because what I'm going to do is work with my training data set and do some cross validation to compare some models. So let's do a linear model. So we'll do linear regression. The default being like linear regression where it's not classification, because I'm predicting a numeric outcome. I'm going to specify the model that I want to use, which is, let's see, do I actually need anything besides linear reg? I don't think so. And I think it's train. What was that? Yes, it's a generic. See, I wish they had more I wish we had. Oh, it's fit. Yeah, that's the one. One thing is, it actually is. I always find difficult to I always find it is a little bit difficult to to get the exact examples. So like here, it's like fit on a model specification. All right, I think I can give it a recipe, but I need to check. I think I can say fit on the recipe. with the data equals training prepared, for example. Nope, it looks like I can't. Isn't that frustrating? Why can't I use the recipe? Wouldn't it make sense for me to be able to use the recipe? I keep forgetting these steps. Let's see. Yeah, that's true. I want to use fit resamples. Thank you. So I'm going to start by using fit resamples. I'm just going to do cross validation, but I do need to resample first. So, yep, I have my recipe. I have my linear model. Oh, I need to do set engine lm. All right, and I'll do. So this is my model where I use a linear model. Then I would say v-fold cross validation of my training prepared. So you're going to do 10-fold cross validation. Each of them has a training set and a test set. They don't duplicate. And I use that on fit resamples. Yes, I do it on. So here I do my split training cross validation. And what I do is I do fit resamples on my linear model. Oops, sorry. Second argument is the recipe. So the first argument is the resamples. Second argument is the recipe. And does it need a third argument? Let me see. Object. On a workflow, model spec goes object, then the preprocessor, then the resamples. All right, so the preprocessor is the paired recipe. All right, so I'm going to call this. I'm going to save it. Yeah, I'm going to take this and save it as linear model cross validation. It treats this as a workflow. And, oh, right, I do need to give it the resamples, which is training CV. Something's missing. Let's see the notes column. So this splits it up, and it shows not all variables in the recipe are present in the training set. Let's take a look at the training set. Training CV, or survey USD training. What am I missing? The recipe is this. It says we have the outcome, and we have. Do I need to process it with the recipe first? See, that felt like it was the opposite of what I needed to do. I thought I could just pass it the recipe. Training CV, yeah, training paired, and yeah, maybe don't do prep. I can try that. That's a good question. Oh, I see. I already prepared it. Oh, woof, 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 woof. Yeah, sorry. I think I can leave in the prep, but I do need to do. This is supposed to be on the training data set. It's not supposed to be on the cleaned one. Nope, not quite. Not quite. Let's see. Job title is in here, and let me try dropping the recipe. It always takes just a little bit of guessing as I'm starting to use these. All right. Yeah, this is way closer. It's giving me some warnings. It's surprised by the NAs in gender. Let me check that for a sec. I thought I didn't have missing data. Nope, we have missing data. So what I'm going to do is throw in a step unknown gender as well. Unknown. All right, and you know what? I'm going to clean that up in the other prefer not to answer. I'm going to do it actually up here because I'm doing the coalesce up here because they actually generally I'd rather that just be lumped in with other. It's missing. It's a type of missing data. So here we go. Survey USD rerun, and the recipe reset up, and the training set I'm resetting up, and I'm still missing something. No, let me just check. I missed some line of code somewhere. One moment, please. Woof. Oh, I forgot. That was the problem. I didn't rerun these 2 steps. So this is now my cross-validated training set. Cool. I don't know what the new levels in the factor NA represents in this case. I can take a look at this, but yep. Oh, this is really helpful from Dennis. Is step novel will take any level that we haven't seen before and turn it and assign like it to a new value. I might want to. I'm going to get back to that one. That's a really good. That is a good idea. But that's yes. Thanks for pointing that out. Yeah. All right. So here now I have this, and I've computed metrics and notes for each. What's great about the metrics? There is a function. What is the? Is it unnecessary? Shoot. There's a word for the metric one. There's a way to pull out the metrics from all of these and compare them. And I just need to remember what the name of that function is. It has been so long. Summarize. Is it summarize metrics? It's a pull metric. Collect metrics. Thank you, Kyle and Jonathan. Yes. So collect metrics. Oof, this is great. All right. So what this does is actually look not within each of these metrics, but it's summarized across all of them. So it says root mean squared error and R squared. 2 good ways of looking at predictive power. These are the predictive power we got. R squared being 0.45. That was higher than I was seeing it before when I was fitting a linear model. Not that much higher, I guess. We saw 62%. And I guess we're adding a little bit more. Oh, my threshold might have included a bit more categories, more degrees of freedom. So it's not crazy. Okay. So this is then a thing we want to try and beat. Is we want to say this is a linear model where we excuse me. Where we combine across all of these. What's great about we combine across these, and now I'll say linear model CV, collect metrics. Cool. One thing we can do is we can tune this. So this is going to be really cool. Is I might want to say I don't want threshold to be. I don't necessarily want to just pick one threshold. I might want to tune it, and I'm read for a moment how to do that. Should I do that right now? Yes, I'm going to do that right now. All right. So there is a whole approach to tuning. Here we go. Where I'd say go tune threshold. Does this work? Let's find out. All right, and I'm reminding myself for a moment. I want to use a tuning approach to say, yep, here it is. In our steps, instead of saying, so I can say like, okay, what am I doing? This, yeah. What I do is I say, okay, threshold is some tunable value, and yeah, I'm gonna call it threshold. Now I can apply this and say linear model tune CV tune threshold. So the idea is I can set different values here. I can set like 0.005 or higher values and such, and I can instead of using fit resamples, I'm going to use tune grid. Let me confirm on this. The first one is the model spec, then the recipe, then the resamples. Okay, so it's a similar approach. What I do need to pass it is a grid of potential values. I like using Crossian for this. So I'd say grid, so threshold is tune. Yep. And I actually don't think I need to say threshold. I think it'll be by default named threshold. But yeah, so I'd say threshold is, what are plausible values? 0.01, 0.05, 0.1, 0.01, 0.05. I'm going to actually put it on a logarithmic scale, 0.03, 0.1. The idea is how common does a category have to be for us to leave it in? So that's like something we could have multiple possibilities. And I'm going to say, okay, we have threshold grid. Grid equals this. Here we go. Whoop. Up. Let's see. The dot dot are not using this function. Oh, I meant to use tune grid. Here we go. All right, I don't know about the new levels in a factor situation, but other than that, what this should be doing is running, for each fold, it should be running one of these, each of these 5. Yeah, you can see it's now on fold 4. It's running each of these 5 thresholds for data preparation. And yeah, that's I think what's really cool about the tune package and the tidy models workflow is I get to not just vary what model I'm using, but vary some of these like cleaning parameters. So I can set different thresholds, see how it affects the predictive power. That's the kind of thing I would have otherwise just done with like a whole lot of guess and check. I could have separated like, okay, how many buckets do I put job title into? What is the threshold for industry? What's the threshold for state? I think I have a suspicion that would be overkill. But yeah, now let's take a look at these tune thresholds. So see, these, and each of these metrics is going to have a value for each threshold, which means I can actually collect metrics and I get a value for every threshold. So I do, here we go, I visualize threshold by the average estimator, color equals metric, geom line. Oh, I want a scale x log 10. Cool. So this is showing actually is doing cross-validation, setting higher thresholds leads to, setting higher thresholds leads to higher root mean squared error and lower r squared. Both of those are bad. So this threshold is definitely too high. But actually it's plausible that setting even lower thresholds, maybe my thresholds are not like low enough yet. So at the very least I can certainly set a 0.001 and I notice that, okay, it is on, my cross-validated train error is really good, even though that's going to be, setting the threshold this low is going to be really, it's going to include a lot of degrees of freedom, a lot of predictors, but it looks like, yeah, that might be helpful in this case. I can include anything that has more than 1/1000th, which in a data set well, my training set was 14,000, means we have at least 14 values in there. Yeah, I'll set this threshold in the future. All right, so that was a little bit of tuning. So I'm gonna now I can say rec with threshold, and I can actually update my recipe. Let's remind myself how we do that. Recipes update. See, I remember all these like things that one can do, and I just forget what the text for them is. Somewhere there's a set, like I can actually set the tune, like I can. Somebody's going to remind me in the comments because I've really been appreciating that. There's like tune. Is it finalize recipe? That looks pretty good. Threshold equals 0.001. Nope. Parameter. Finalize recipe takes a list of parameters. Loving it. So I can do this. I could have used, yeah, we saw that I think there are other ways to pick out the best one, but I just do it manually, and now I get my recipe with threshold. All right, so I'm gonna run this again just to get this like written down. I'm gonna say, okay, linear model CV, and I'm gonna say I can drop this and do fit resamples. So this is the cross-validated performance. Oop, I did something wrong. Oh, I need the recipe to be the recipe with a threshold. And then I'm actually going to compare it to, let's say, a random forest CV. So I can specify rand forest, there's a more complicated model, and I can say, let's do a that allows for the great thing about a random forest is it allows for interactions between terms. So I can take a rand forest, set engine to ranger. That I think is what I like, and let's see. I'm also going to need to have some tunable parameters. So I'm going to say rand forest takes a couple arguments. It can take mtry, the number of predictors that are randomly selected at each, and trees. So the okay, I'm going to use I'm going to say mtry is tune, and I'm going to use trees is tune, and I'm going to fit. Should I do fit? Should I? Sorry, pardon me. I should do tune grid. Should do grid. I can do grid. I can do tune Bayes. Bayes will choose. I think generally find ways to do to like basically select the parameters itself instead of having me specify them in advance. I think it takes a bit of a smarter gradient descent approach to parameter optimization. So I can do, and now I am going to do the recommendation with a threshold. So random forest tuning for both the number of splits and the number of trees, and the and apply the recipe with threshold to the training. Oh, huh. I don't think I have Ranger installed. Let's find out if that beat it. Nope. Should have caught an unknown mode. On mode is going to be, oops. I don't know why what happened there, but mode is regression. It's not classification, and that does not care for that. How does I expected tune Bayes to be able to, these arguments contain unknowns. I expected this to quote just work. That's a little bit surprising because this is supposed to be able to be tuned. One possibility is that finalizing the recipe caused a problem with the tune Bayes, which if that's the case, I've got to kind of I'm going to test this. This is not ideal if I have to repeat this whole thing, but set a threshold of 0.001 rec threshold 001. I'm going to call it that. If this were, nope, that's not what caused the problem. Okay, that's at least a good sign because it means I can go back to using rec with threshold. I was concerned that maybe the finalize of something else had caused a problem. So this one has arguments that are tunable, and let me try tune grid. All right, I don't know why tune Bayes didn't work and tune grid did not do the unknown. Wow, this one is a slow situation. I wonder. Oh, whoa. I'm just trying to kill it for a second. I'm gonna try something a little different. I'm gonna try just putting in mtry is 2, trees is 10, and let's see what it looks like. I don't know if it was just slow as opposed to like, oh, missing data in columns. All right, it does not like the missing data. That's a little odd because I thought that I did in the recipe with the threshold I thought would have fixed the missing data. See, I do step unknown on job title. I would have expected here if I do. Oh, I remove the prep is one thing. But I do want to remove the prep here. Well, I'm still gonna. Yeah, learning how to learning how to do this. The prep prep the rec with the training is it's a little. Oh, I think I can juice instead of baking, but I'm never quite gotten clear on what each of those are. What I'm curious about is, does this have missing data in job title? Oh, nope, this won't work because it's still tunable. I need to do rec with threshold. And now I have all these job titles. All right, that didn't seem to cause any problems. Rec with threshold. Excuse me. Yeah, I don't quite see how. I really expected the unknown to work. Filter isn't a job title. And none of them are actually missing job titles. So I don't know, like none in the training data have a missing value there. So I'm a little puzzled as to how, as to what I'm doing wrong here. Tell to replace these is unknown. Tell to do the other ones, and then I'm doing oh, this is the linear one. I already have that value. Missing data in columns. See, that's what's so odd to me, is that the no tuning. Oh, I did want 30 samples, but it still caused the problem. Okay, let's take a quick look at this. The training CV splits one. This is the train, and now if I look at one training set and I apply the recipe to it, so what I do is I would say juice bake rec with threshold. Nope, it's new data equals dot, and I should have prepped the rec with threshold. There it is. So what's confusing me is that it's saying there's missing data in this, say, this first column. So I'm like, just right now I'm in debugging mode. So if I do like filter is NA this, no, I actually don't see any missing data in the first column. Do I see any data in the first column? Count, job title, account executive, count. Yes, I see 13 values in the first data, even with the missing one. So why was random forest really failing there? One possibility I'm starting to think about is it possible that, and let me run this one more time, see what the full error was. Oh, I see. The missing data is different in each of these. Aha. Okay, what I just realized is we have to, oh, that's a prep step. All right, so the problem with this is that we haven't, there's something for removing values that have absolutely no variation. So step, yeah, so step, so Ravi's just in step novel. I actually think what's happening is that in like that first one, job title account manager had no data. Nope, I'm wrong. In that first split, it seemed to. My suspicion was, all right, yeah, let's try step novel, see what it does. So step novel. Taking a recipe would say, step novel. Where's step novel? Oh, okay, so I just say, all right, I'm going to do this after step other, say step novel, state, and start with these, and throw an experience. I can do all nominal, I think. Nope, that didn't seem to fix the problem. Well, if I did, yeah, I did rec. I do rec with threshold finalized. Novel factor level assignment for all nominal, dummy variable, small nominal. And that didn't seem, oh, step NZV. Aha, thank you. Really near zero variance. Ah, I was looking for that one. Yes. Step NZV for all nominal. No, actually it won't be nominal once I've done, now that I've turned it to a dummy variable. So I'm gonna still do it. I'm gonna say step, oh, I guess can I do everything? Step NZV, can I just say everything? How's that look? Oh, I didn't rerun this step. Sparse unbalanced variable filter on everything. Haha, still not working. Closer actually. Yeah, notice now I've got not closer necessarily, but it's not showing the same thing. Missy did and call. Okay, it looks like maybe adding the other variable. I wonder when I added other. So this is kind of like, it's really, Thema is like so convenient, but it's also can be tough to debug because the bugs happen somewhere deep inside, and I can't see the prepared data. If I let's see, if I new level missing data in columns. Is there a step here of like, I'm doing this other step, other threshold. Maybe there were ones that yeah, let me see, was it step other? Yeah, we created this other level. Industry computing or tech. I wonder how common that was. Was that, if I increase the threshold, does it get any less buggy? I'm just a little bit curious. Like, is that gonna fix anything? Nope. What if I increase it by a whole bunch just to see if I can get something out of here? Yeah, definitely. I'm definitely open to ideas. Yep. And thanks for your patience as we're watching. The notice I said higher values like industry, computing, or tech. That, when it says missing data in columns, I really wonder if I take this. I'm going to go back to that step where I took. This is my debugging strategy. Is I'm going to take the first. Where to go? Yep. I'm going to take the first split, take the training set, bake it, and prep it, bake it, select contains, what was it, job. It was an industry, it was computing or tech, and count industry, computing, or tech. This had plenty of data in the test set. Now I wonder if I do, instead of training, testing, I still see, like if I take the first, this is what I'm looking at, is like, I'm looking at industry computer or tech, industry computing or tech, and I don't see, because I'm looking at just like the first split. I wonder if I'm prepping the data wrong. Maybe I need to prep. Like I'm taking this recipe, I'm prepping it, and then I'm yeah, I'm not going to try this for too much longer because I'm just so out of my league here. What we got? Yep, so an idea of, oh, okay, so one idea is use the use models package. It's going to get from Jonathan of get boilerplate code. Oh, no, I think I already have it. Nope. I don't want to restart R. See if it caused any problems. So this is supposed to create, oh, nope, it caused problems. Do a quick refresh of the data. Server USD and create library. There we go, create my training testing, create my recipe, set my recipe, and let's check that I'm still good, and create my training cross-validation. Still got my performance. Oh, look at that. And now I'm getting a different error than I used to. I'm seeing like new levels in some of these, and that's actually, that is one of the, I think I've got to figure out how to fix, is that there are new levels to, oh, and this should really be a 1. There are new levels getting added in each of these steps, and I don't see how, like, I think that's supposed to be handled by somewhere here. I'm not 100% sure which one. Maybe I have to put the step novel earlier on. Actually, that might be the story, is I want to put novel early on, either before, yeah. I'm going to try a couple things. I'm going to try putting it before I do other. Nope, that still warns that there are new levels in a factor, and I bet we still get an error. Missing data in columns. What if I put this even, well, what if one thing is, what if I just, I hate that levels of education is complete is not a factor. But state isn't a factor either. I don't see why, never mind. That might not have been a necessary step, I'm not that sure. Right. New levels in a factor, I'm still seeing them. What happens if I put this even before unknown? Or yeah, even before unknown. I would have expected me to do other first. This might actually be working. I'm not 100% sure yet. The linear version might be working. All right. Ooh, thank you for sticking around. I have no idea how people have patience to watch me debug code. I don't know why people have patience to watch me make graphs either, but yeah, they're going, all right, that one worked, and now let's find out, if I take the rect width threshold, apply it here, yeah, you know, I think that might have been the problem. So let me clarify what that problem was. I think I need to put, putting step novel seems like it was the right move. Thanks so much, Dennis, for bringing that up. It looks like that has to be the first step. Otherwise, step unknown will cause problems. I'm not 100% clear on how that works, but the yeah, and I might want to explore a little bit more. But but at the very least, we are unblocked. Woo! All right, and now I can collect metrics on random forest example. Okay. So, for instance, the RMSC, relative, so random forest with, now was this the threshold, just checking, was 0.01? Yeah. This was actually a less effective model than the linear model with the linear model on cross-validated within the training set. The RMSE was higher, the R squared was lower, right? We saw earlier what the, and I'll review again what the linear model CV is, collect metrics. But in fairness, we have too few, we're doing this on very few trees right now. So the, you know, I saw different, you know, it's funny, I had different values when I was looking at this earlier. What did I do? Something about that changed that recipe, caused some problems. I wonder if the, yeah, something lost some signal, because right now it's like okay, the linear model is only a little bit better, higher lower RMSE, lower root mean squared error, but it's not much better, huh? So the so something about putting step novel made the linear model worse. If I take a look at my, what is it? Survey USD training, bake, oh, nope, sorry. I meant to do a prep recipe with threshold, and then bake on data on the training data. I used to get I used to see 88 degrees of freedom, 88 parameters that were being fed, and now I'm seeing 25. So even though the threshold is really low, and one thing I'm noticing here, yeah, where's my job title? I lost the job title. It's like it just disappeared. Even though the threshold is very low, I wonder if that job title got lost in that novel step or in one of these steps. It could be the NZV step actually, and I might want to take. Honestly, I wonder if I can just drop this because it turned out not to be the cause of the problem. Or I can decrease the frequency cut. So yeah, I'm gonna try dropping this. It's gonna slow it down a little, but then I try. Sorry, move it, set the threshold. Well. Oh, but you know what? Did I tune this threshold with NZD? No, I think I didn't. Yeah, I'm not sure what the rank deficient fit must be misleading. It could be that we had too many collect metrics. I'm not sure what that causes. Yeah, we do. That does have a higher R squared, lower root mean squared error. It is a better cross-validate predictor. So I'm gonna keep it like that, and then I'm gonna do the same thing for random forests. Let me check that approach that I just had, where I baked the data. 210. That's actually too many. I think that's a few too many. I don't feel. Oh wait, you know, I fit it earlier and I saw that it was the best root mean squared error, so I will stick with it. Or you know what? I'll go up a little bit. It wasn't a huge difference. I'm gonna just casually do this. Why am I doing that? Because I want to do random forest, and random forest is slower the more terms you have, and I want to just try a random forest. All right, I'm gonna actually do random forest grid. No, I'm not. It's gonna be too slow. So what I'm doing is trying out this random forest, just splits of 2, 10 trees. And then we see how's their performance. Aha! This is not that much. Let's see. R squared 0.33. What was it on linear model? 0.44. So lower root mean squared error. Okay, but I'm getting a little bit closer, and now we can actually try tuning this. So let's make this be our last thing we do today, is get a grid of m try is either 2 or 3. Trees is 10, 30, 100. It's actually quite a bit of tuning. How can I tell it to be verbose? Is it going to be verbose off the bat? Is it? Maybe. Let's find out. Should have called this random forest tune. So as I want to tell me when it's done running each of these folds. Anybody know how to make it verbose? I don't know how to make it verbose. These so many models to fit 6 times these. Ooh, I should be using parallelization. Let's set that up. and remind myself how to set up a back end. I have some register. This had been a while since I did this. Yeah, just gonna tune for a while. Let's let it sit for a little bit. But what it'll end up telling us is you have 2 trees if you have 3 trees, and if you have if you have 2 types of 3 or 3 types here, we have our results. Random forest tune, collect our metrics, and now I can say trees mean geom line color equals factored m try, and facet wrap. Actually, I'm only going to use root mean squared error. Actually, I've been using r squared from early on, so I'm going to use filter metric is RMSE. Is r squared. I've just been using that for a while here. Yeah. So the question is, how good is our y is mean squared error, and color is number of splits. X is number of trees. So this gets at why we don't just use 10 trees and we don't just use 2 splits. Is we really do get better cross-valid performance with a larger number of splits and a larger number of trees. 100's a good start, but really we'd want to use a little bit more. Let's. I said it was the last thing let's do, but I'm so excited because we're finally getting some predictive modeling. Let's figure out how to use some parallelization, and let's do it on a larger number. And we'll do, and let's also do, let's see, for register parallel for each register. There's a setup here where I can say why can't I find the approach to registering? Register do parallel. All right, I'm going to use that. Oh, it's do parallel. Yeah, okay. I think I've done this before. Register do parallel cores. How many cores do I have? I don't know, but it's probably 8. So I'll go ahead and say we'll use 7. Thanks, Robbie. Yes. So I'm going to use do parallel to register 7 parallel cores. I think that's probably safe. I don't know for sure. I think I have 8 cores. So, we'll find out. Or will we? And I'm going to use 2. Let me see. I'm going to do a couple things. I'm going to do training CV5 because I'm going to use fewer folds. V equals USD training V equals 5. Okay, because that'll be a little bit faster. We'll only have 4 folds, and I'm going to do 30, 100, 300, and should I try 4 splits? Yeah, why not? I got a lot of terms here. So I'm going to do 9. Yeah, I'm going to do, because I saw 10 was not very good, so I want at least 30, 100, 300 trees. Training CV5. This is my grid. I've parallelized. Let me confirm that I don't need to pass anything to tune grid to tell it to take advantage of parallelization. And while it's running, we're going to review through the what we've been looking at. And where is it? The yep, it just says to execute the resampling iterations. All right, in parallel, I just use this. Yeah, so run the sure this is run, and here we go. Okay, while this is running, we're going to review a little bit some of the stuff that we did today. So I did a lot of it, I'm not going to pull open most of the plots, but yeah. What we did is, yeah, I won't be able to get to the old plots. Oh, and I didn't do the old plots in the same session, that's true. All right, we looked at a couple categorical variables. It's always good to understand first, like, what's the distribution of them. Then we looked at the distribution of salary, saw was log normal, roughly. So we knew we'd be predicting salary on a logarithmic scale. created a quick tidy eval function, plot categorical, which let us quickly look at how it's different between states, industries, job title, overall, in-field, and we started to get a sense of how we might use some of these columns in a predictive model. Certainly we saw that some of them did seem to be pretty important. So then we started with a linear model and did a little bit of statistical exploration. I've got my session back so I can pop it up. We saw there's a lot of variation within and between, but if we use we can look at like R squared and say, okay, a model just based on predictive in field gets an R squared of about 11%. Then we look at things like the effective job title, and we tried comparing across many different effects and saw which are the most important and which are less important. So industry and experience in field have a lot of impact, and maybe others like race have a little bit less. So then we said, let's try doing a predictive model to predict salary based on, we said let's do the salary, but let's actually do it using the tidy models framework. We use a series of, they created a recipe for cleaning our data, which is really critical when we're going to be working with training and testing sets. So we set up this recipe, tried cross-follow validation on linear model, and we used that to come up with the appropriate threshold for the grid to say, like, I'm going to put everything rarer than a certain amount, in this case 0.001, we're going to put into an other bucket. It turns out we actually can be pretty aggressive with that, which we discovered so quickly. If we do if we do a tuning on this, we were able to see that maybe saying a really low threshold was able to get a better R squared than saying a higher one. And remember, this was all done on tenfold cross-validation, train on 90%, test on 10%. That's the great thing about these tuning functions, this resampling approach. I'll give this a second while it's running, and then we'll be able to see that graph again. Yep. Yes, we saw like, okay, our best threshold was at like 0.001, highest R squared, lowest root mean squared error. All right, once we did that, we said, okay, now we have our performance for a linear model, and that looks like this, an R squared of 0.45, and let's try taking a look at random forest tuning on, all right, here we go, number of trees. One thing I see is once you're past 100, not a lot of benefit to going up to 300 trees, but there was a benefit to going up to 4 splits. And yet, this is kind of interesting to see. For this, so far, none of these models that I'm trying, if I do linear model metrics, performance of a linear model, even without regularization, which is actually kind of crazy, I should have been adding some regularization. Even with this performance, if I take a look at these metrics and I get just the mean, what is that, 2 is going to be the R squared, then I could actually add in a like geom H line where y-intercept is here and say here's the performance of a linear model. And actually in this section, the random forest couldn't catch up to a regular linear model. So oh my goodness, thank you for asking. This is not a mean squared error. This is R squared. Oh boy, bigger mean squared error is worse. Thanks, Guilherme. Sorry, I don't know how to pronounce your name. Guilherme. But yeah, this is R squared. I know because I did metric as R squared. So R squared is percent of variance explained. A higher one is better. If I change this to RMSE, the square root of the mean squared error, lower, I would have been lower with higher number of trees or more splits. So one thing this suggests is that I could keep increasing the number of splits and it might catch up to linear, but I also might be able to improve a linear model by adding some regularization. We didn't even have a chance to do that today. All right, so that covers it for that. Definitely covers everything today. I've actually spent 2 hours today where we spent a little exploration and then a lot of machine learning. I'm expecting in the next 5 weeks as I'm prepping for this coverage, I'm going to want to pull out tidy models a little bit more. I really, as you can tell, I'm really rusty on it and I could really use some practice. All right, so thank you so much for joining. I hope you found this as useful as I very much did when I was starting to remind myself how tidy models work. If you liked it, if you enjoyed today, please be sure to like and subscribe. I hope you had fun. I certainly did. I'll see you next week.